One of the things we're going to want to calculate is the half-life of a radioisotope. So what is the half-life? The half-life of a radioisotope is the time required for the radiation level to decrease to 1/2 of its original value. So it's a length of time, and it's the amount of time it takes for half of your sample to disappear or to have disintegrated. So the Dead Sea Scrolls were dated with carbon-14. Let's jump into our first problem. Technetium-99 has a half-life of 6 hours and is a pure gamma emitter. Suppose 80 milligrams is prepared. How many milligrams would remain after each of the following intervals? So, if we start with 80 milligrams, and we have one half-life, half of it will be gone. So we'll have 40 milligrams. If we start with 80 milligrams, and we have two half-lives, well, the first half-life will take us to 40 milligrams, and the second half-life will take us to 20 milligrams. Each one of these arrows is a half-life. And I'm just dividing it in half each time. Now the next problem, they didn't give us the number of half-lives. They said 18 hours. So we're going to need to convert our hours into half-lives. We know that from the original problem that 6 hours is equal to 1 half-life. So 18 hours we use this as our conversion statement. We want hours on the bottom, 6 hours, and 1 half-life. So we'll get 18 divided by 6, that's 3 half-lives. So if we start with 80 milligrams, our first half-life takes us to 40 milligrams, our second half-life takes us to 20 milligrams, our third half-life takes us to 10 milligrams. So that would be our answer. We'd have 10 milligrams left. What about 24 hours? Well, again, 6 hours is equal to 1 half-life. 24 hours. We want to put hours on the bottom, so they'll cancel, and we'll put our 1 half-life in the top. Goes in 4 times, so we get 4 half-lives. I guess we'll start with a B. And we start with 80. Our first half-life takes us to 40. Our second half-life takes us to 20. Our third half-life takes us to 10. And our fourth half-life takes us to 5 milligrams. And that would be our answer. Okay, let's work another problem. The radioisotope of strontium-90 has a half-life of 38.1 years. If a sample contains 36 milligrams, how many milligrams would remain after 152.4 years? Okay, so we look at our problem here. We're starting with 26 milligrams. We want to convert, though, our milligrams into our years here into half-lives. So 38.1 years is equal to 1 half-life. We'll start with our 152.4 years. We'll put 38.1 years in the bottom and our 1 half-life in the top. And we will discover that we have 4 half-lives. So we're starting with 36 milligrams. The first half-life cuts that in half to 18. The second half-life cuts it to 9 milligrams. The third half-life cuts it to 4.5 milligrams. And our fourth half-life cuts it to 2.25 milligrams. So each half-life, I'm just dividing what I have by 2. Okay, I've got this labeled as a challenge problem. Let's look at it and see if we can figure that out. Carbon-14 is used to determine the age of the Dead Sea Scrolls. The Dead Sea Scrolls were determined to be 2,000 years old, and the half-life of carbon-14 is 5,730 years. What fraction of this half-life has been used up? So let's start by writing kind of what we know. We know that 5,730 years is 1 half-life. And the amount of time passed is 2,000 years. So what if we take 2,000 years and we convert it into half-lives? How many half-lives is that going to be? So we'll put 5, 7. Years goes on the bottom, and our 1 half-life will go on the top. And we end up with 0.3. So that's the fraction of the half-life that's passed. The half-life of iodine-123 is 13 hours. How much of a 64 milligram sample is left after 36 hours? Well, 13 hours is equal to 1 half-life. We have 36 hours, so 36 hours divided by 13 hours, 1 half-life. Oops. And we discover that we have 2 half-lives. Start with 64 milligrams. The first half-life takes us to 32, and our second half-life takes us to 16.